Hey everybody, this video is an introduction to perpendicular lines. So let me first create, using Geometry Sketchpad, perpendicular lines. So I'm going to create a segment here. I'm going to put a point on it. And through that point, with the point highlighted and with the line highlighted, I'm going to construct perpendicular lines. So the program needs to know what point through which we're going to create a perpendicular line. And what I'm going to do now is I'm going to put a point here just because, and I'm going to put a point here just because. Alright, what I can do is I can hide this line here. So I'm going to display, hide that line, and I'm just going to highlight these and connect them. Control L. Alright, so I created perpendicular lines, and I'll label them up. We'll say D, how about that? E, F, and G. So for this particular diagram, I would write that the segment, and we're going to call the segment DE, and I'm going to put is perpendicular. Whoops. Here's a perpendicular sign right there to and segment FG. And then I'm going to go back and put the proper notation, segment or segment here. Okay, so that's how we write perpendicular. DE is perpendicular to FG, and what perpendicular means by definition is they meet at a right angle. So the definition, lines that meet at a right angle. Of course, right angle is 90 degrees, right? So here we could verify that. I'm just going to measure this angle right here, let's say. It doesn't matter which one. You'll see why. F vertex D. I'm going to measure that up, and yeah, we get 90 degrees. How about that? Okay, so that angle is indeed 90. Now, the way we note that on a diagram is we put a little box, 1 and 2. And that tells you that we know for sure that those particular lines are perpendicular, and therefore, by definition, we have a right angle. Now, from the definition, we get lots of things. Okay? So not only do we get the lines that meet at one right angle, we get lots of other things. So here's what else happens. Dot, 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 dot. Okay? And it comes from the definition. So kind of the definition gives us a right angle, and perhaps you're reading ahead in the future and can tell what's going to happen, but a lot of other things happen too. Another thing that happens is if this angle is 90 here and these two angles are supplements, they add up to be 180, then this angle here has to be 90 as well, right? So that's 90 degrees as well. Okay, and now this angle is 90 and these are vertical angles, then they have to be equal. Therefore, this angle has to be 90 degrees as well. Okay, and this angle right here is vertical to this angle. Therefore, these two angles have to be equal. Since this angle is 90, this angle has to be 90 too. Alright, so obviously if one angle is 90, then all the other angles have to be 90 degrees too. Right? So that also happens. Now, since they're all 90 degrees, they have to be congruent because they have the same equal measures. Equal measure angles, congruent angles. All right. So by definition, we get just this piece, a right angle. And of course, if we have a right angle in this particular diagram with perpendicular lines, then we have really 4 right angles and 4 congruent angles because they're all 90 degrees. Okay? Here's a little different way of looking at perpendicular lines, and we're going to get a little coordinate plane action going on here, and here's what it could look like here. On the Cartesian or coordinate plane, perpendicular lines have slopes that are opposite, so if one's positive, one's negative, and reciprocals, 1 over. Reciprocals, no. There we go. Okay. So for example, I can look at this particular example. Let's graph up a new function, and let's call it y equals maybe 5x plus 2, right? So that line has a slope of 5, right? 5 mx, slope intercept form, and a y-intercept right here of 2. Okay, so a line that's going to be perpendicular to this guy has to have a slope which is the opposite reciprocal of 5, the slope of this line, right? So the opposite reciprocal of 5 is negative 1 over 5, or negative 1/5. So I'll go ahead and graph up another function that's perpendicular. And it could have any y-intercept as long as the slope is negative 1/5 times x and plus 4. So it's got a y-intercept of 4, slope of negative 1/5. Oh, and there we go. Okay, so here's my negative 1/5 slope. Here's my 5 slope. And you'll note that these lines are indeed perpendicular, therefore this is a right angle, and all the other angles are right as well. Right, slope negative 1/5, slope of 5, opposite reciprocals, therefore perpendicular. Additionally, parallel lines have same slopes, but different y-intercepts. So if I wanted to create a line that's parallel to 5x plus 2, I have to have a slope of 5 in that other line, but so 5x minus 4, right? Same slope 5, but a y-intercept of negative 4, right? And so here are my two parallel lines, 5x minus 4, 5x plus 2. They both have the same slope, 5. Okay, this is an interesting theorem we'll get to later. Let me see if you can follow. If these two lines are perpendicular and these two lines are parallel, what do you think we can say about these two lines? All right, thanks for listening. Hope you enjoy the perpendicular lines tutorial. We'll see you Monday. Have a great weekend.